Hello everyone, welcome JEE enthusiasts. Today is a very special ride. And long time ago, people wondered why things move. Why does the apple fall? Why can you move ahead on a rough road? Why is it so difficult to walk on an icy surface? How can you jump? Why do you fall? Why do you get hurt? So the cause of motion, that's dynamics. And let's get ready for this amazing ride where we are going to see why things happen the way they happen. So today is Wednesday. Let's get going. We must do this. We must. And you might know who this character is if you have been watching Star Wars. So anyways guys, that is me, Shreyas, your master teacher for physics, going live from the Bangalore studios at Vedantu. And I've been teaching for quite some time and I love physics and I love teaching. That's why I'm here. I want to spread this knowledge to as many people as possible. So welcome aboard this very special JEE English channel. Yes, this is the very unique channel in our country which has amazing master teachers, and you have full preparation for, you'll get full prepared for the next year's exam and even the exam after that. Yes, so welcome aboard, be it in 11th, be it in 12th, be it a dropper, you guys are all welcome over here. So this is a very unique channel for JEE English preparation. Welcome. I was just reading all your chats when I was just sitting down before I enter over here. It's nice to see everyone forming a nice community. Welcome Krito, Uncharted, Saurabh, Khushi, Akhil, VSG, Navmi, Sonu, Piano, Chini, Saurabh, Sankar, Science, Divya, Ram. Very good Ankita, welcome aboard. How are you guys? How was your day? Hi. I've been reading all your comments. Yes, I read all your comments. I hope you guys are really fresh now. By the way, the chemistry class is postponed because, Sir has to still set up the studio. So it's taking some time. So hold on for some time. Sir will be back, right? So chemistry lecture will happen very soon. Don't worry. Well, I don't know Telugu, but I have some roots from, what do you say? Andhra Pradesh. Like my dad is from Andhra Pradesh and my mom is from Karnataka, and I have been staying in Maharashtra. And guess what? I was born in Tamil Nadu, guys. Yes, did you know that? I was born in Tamil Nadu, by the way. And yeah, anyways, I'm a Maharashtrian by whatever you say, like all my ancestors. Yeah, so it's like a complete mixed breed, you can see. So nice to see all your love and all your smileys and all your hearts. And wow, look at that. Everybody is from different parts of the country. Is anybody from Dubai? Is anybody from out of the country? Is anybody from some other country out here? Wow. Yes. I don't know so much Telugu, Puffy, but I have seen a lot of Telugu movies, by the way. I have seen all kinds of movies. So yes, I have seen Tamil movies also. I like Tamil movies as well. I'm from Salem. Yeah, Salem. Yeah, okay. Okay, wow, somebody is from Madhya Pradesh. Look at that. Wow. So cool. Everybody is putting up where they are from. Acha, somebody is from Bihar too. Okay, somebody is from Kerala. I remember somebody was from Andaman Nicobar as well. I remember somebody was from Andaman as well. Yes, amazing. Great. Haryana, Odisha. Wow, look at that. Jharkhand, Maharashtra, Kasakai Bara hai. I am Mumbai. Acha. Okay. Look at that. Somebody's from Nepal too. That's good. Okay. Okay, great. So guys, today we are going to study Newton's laws and we are going to see amazing ways of FBD. You might be like, sir, I know how to draw FBD, but I'm going to change your mind. You will be like awestruck. You'll be like, oh, I didn't know this. Is this so? I thought this was that. So that's the kind of reaction I'm expecting from all of you when we study some problems. And tomorrow we are going to see problems on pulleys and strings, and I'm going to combine the drills of these two because just having drills on this part is difficult. So we're going to combine these two sessions, drills together, and you will be having a separate assignment on these two things together. But the number of problems will be, of course, more. It will not be 5, it will be more than 5, combining both these things together. Okay. And I also remember students commenting that the extracts are not yet out. So guys, there has been a technical difficulty. Just hold on. The person in charge will take care of it. I have already informed the backend team, so do not worry. I know, guys, I have promised you extracts of 1D, 2D and all other chapters. I am going to give it to you, so do not worry, I'll give it. Okay, so yes, by the way, Menti quiz, guys, please understand, it's for the lower grades. You have leveled up. In 11th and 12th, it's not just about just solving some objective questions and feeling happy. I know you get excited when you see your names on that Menti quiz leaderboards and stuff like that, but we'll conduct it maybe sometime later. But I feel we should solve more of subjective JEE oriented problems. You guys now are in 11th and 12th, and some people are even droppers, so keep that in mind. Yes, you're a little bit more matured, so guys, you should find joy in different kind of things now, like seeing some amazing problems, seeing the solutions. Yes, it's good for kids, but not for 11th and 12th. Please understand that. Thank you, guys. Thank you very much. Well, Athar, nice to know you're from Maharashtra too. Okay, yes. So formula quiz, you know what, guys, I have planned some amazing sessions just before JEE Mains exam. So all the droppers and the 12th standard students, don't worry, we have you covered. I have planned some amazing sessions. In fact, all three of us have planned. We are going to come up with crazy plans once we are done with the major portions. Just before the exam, 1 week before the exam, don't worry, we have you all covered. Okay, somebody's from Mars. Okay. Anyways, so guys, if you are new, please do not forget to subscribe and do not forget to like the video after the session is over or even between the session, right? If you love me, if you like me, please don't forget to express all your feelings through the comments and the likes out there. Okay, great. So let's begin the session. So why does motion exactly happen? Motion happens because there is a cause for that motion. Without any cause, there is no motion, of course. So if a ball is thrown, it will change its direction or it will change its speed because you strike it with a bat, or maybe you kick it, or maybe you punch it, or maybe some other ball comes and hits it. So that ball is applying something called as force. That's what we are going to see, and that is the cause of motion. That's what dynamics is. In kinematics, you never bothered why things are happening. Dynamics deals with why things are happening. Kinematics deals with how things are happening. How fast is it accelerating? How much distance did it cover? You never bothered why did it do that, whatever it is doing. All right, so that's motion, dynamics, and in a brief. So obviously now you'll be like, are there any rules? Like you have traffic rules, there will be some rules to govern the laws of motion, and that's what Newton gave hundreds of years back, and we still obey them. How cool, right? We still obey the laws given by Newton. Well, I was just kidding, guys. Newton did not give these laws. These laws were already there. He just discovered them. That's it, by experiments and careful observations. It's not that before Newton, oh, there was something else, there were some other rules. No, it was still there. Understand? Okay. So what are these rules? So let's see. So first thing that I want to talk about is inertia. What is this inertia? Inertia, I have a very good slide to explain that. Look at this. This car falls back when the truck moves ahead because the car was not tied to the truck. And in that case, look at that nice cute looking, I think it's a bear, yeah, or a panda. Okay, I cannot see because the light is getting reflected. Yes, it's sliding on a smooth surface. It's sliding on a smooth surface. It has some mass, it has some inertia, and it is maintaining its tendency of motion. Just like this car was at rest, it is trying to maintain its tendency of motion or state of rest. This car was not tied to the truck. As soon as the truck moves, this car said, hey, you know what? I want to stay there. I have mass, I'm going to stay there. And just like this panda out here, who will be like, okay, I'm moving, I'm going to continue moving unless you stop me. That's what they're going to say. So what is inertia basically? So inertia is nothing but resistance to change the state. Now this state can be of two types, understand? It's not Maharashtra, Karnataka, Andhra Pradesh. Well, it is basically the state of rest or the state of motion. And who has more inertia, right? The person or the object which has more mass has more inertia. So understand, inertia is measured. How is it measured? By mass, and mass is generally in grams or kgs, depending on whichever units you are using. So more the mass, more the inertia. A heavy truck will be very difficult to start as compared to a small car by the same force. So imagine if this was an elephant. Just imagine, guys, this was an elephant sliding on the smooth surface. Can you just imagine how difficult it would be to stop that elephant sliding? I mean, it's so funny just to imagine it. So same way, if this was, a small object, probably it would have been pulled by the truck because it has less inertia, but this heavy car just falls back because it was not tied. Okay, I hope this is clear. Yes, very good, very good. Great. I hope you guys are understanding all this. So let's go now. Using this, in zero gravity also there will be inertia. Yes, in zero gravity also. So inertia is a property of the body. It's not because of gravity. Gravity gives you weight. Inertia is because of mass, and in space also you have mass. Understand that, okay? Yes. So just like, let's say you are in space, and let's say there is one heavy rock in space. You want to push it. You want to push it to someone. If the rock is heavy, you'll find it more difficult. So that's why it has more inertia. All right? Yes. I hope that is very clear. Now, let's come to Newton's first law. Newton's first law in a gist is exactly this. How many of you have faced this? Please let me know. How many of you have faced this? How many of you have faced this? Please let me know. Come on. Okay, Pafi ready, Mr. West, Uncharted, Krito also, piano, science, Anu. क्या बात है, everyone almost. बहुत ही बढ़िया, मजा आ गया. अच्छा, everybody would have faced this in life. So that is Newton's first law, but that was a different way of explaining to you. So what does Newton's first law say? It says a body maintains, right? So you can keep writing, please keep making notes. I have been telling you, please keep making notes. Do not sit idle. Maintains its state of rest or motion, but that is uniform motion, unless acted upon by an external unbalanced force. Okay, so a lot of important words over here. We know what does this first part mean. A body maintains its state of rest or uniform motion. Just like we saw in that case of that panda or that bear, just sliding on that smooth surface. It is maintaining. Why is it maintaining its state? Just recollect that previous slide. It was maintaining because there was nothing to stop it. You might be like, no sir, but it experienced weight. Oh, hold on. There was also one more force from the ground, which you will see soon, that it is called as the normal force. That normal force and that weight cancelled out each other, and there was no friction on that smooth icy surface. So the panda maintained its state of uniform motion. Unless there was some unbalanced force. The unbalanced force means something which does not cancel out. So there is a resultant force. So the forces are there, but they do not cancel out. That is called as unbalanced force. So if there was friction, there's nothing to balance friction, so it will stop eventually. In that case, first law obviously is not followed because there is an unbalanced force. So unless you apply an unbalanced force, the body will continue to maintain its state of rest or uniform motion. And what is this external? External means, imagine if the panda was sliding and it applied a force on itself. It tried to push itself. It will not stop. Just like if you're standing here and if you push yourself, will you start walking? Obviously no. Somebody has to push you, or you have to push something so that you experience a force. That force is external force. I hope this is clear. Yes, so I hope this is clear. Yes, please let me know. Please let me know in the chat box, guys. Amazing, amazing. So the thing is, only when somebody pushes an object from outside will it move. An internal force, a body which has lot of forces internally, that cannot make that object move. Understand that. So why do you move? Think about it. Because there is friction on the ground. And is friction external or internal? Think about it. It's external. Why is it external? Because if you consider you as a system, then understand the friction is acting on you from the ground, and that is propelling you ahead. You can walk only because there is friction. Just imagine there was no friction. No matter what you do, you cannot move. Understand that. I hope this is clear. Great. Now, having said that, guys, stick to the topic. I'm seeing you guys are deviating from the topic. Sudhakar, Krito, thoda topic ke andar raho. Okay. Yes. So this is the first law of Newton, and this example clearly demonstrates that. So unless there was an external force, a body continues to maintain its state of rest or inertia. That's what you can say. So now you might be like, sir, what is force? So what is force? So force is something which causes motion. That is the simple way of saying some things. So if an object is moving, you can change the direction or the speed by applying force on it. So force is something which changes the direction or the speed of motion. That's what you can say. Yeah, it's the cause. Like over here, can you identify the cause why that woman fell? Is this panda responsible? Is this panda responsible? What do you say, guys? Yeah, has the panda applied some force? No. Okay, so actually I wanted to tell you there are two types of forces. One is a contact force and second is a non-contact force. Yeah, so this is just a joke, guys. Please don't take it literally. Okay, so the panda did not apply any non-contact magical force. There is nothing called as magical force, first of all. Okay, so what are the two types of forces? One is a contact force, second is a non-contact force. Now contact forces is the one where you see that through your naked eye, the objects, the surfaces touch each other and they apply forces. Like you pulling somebody, you pushing an object, those are contact forces. But you taking a magnet and pulling something, you would have all tried it when you were kids, right? Pulling something using a magnet, that is a non-contact force. Or even for that matter, gravity. So a magnet pulling something or gravity pulling an object or some other planet, then all these forces are basically non-contact type of forces. Very good, very good. Okay. Now, let's talk about the contact forces, non-contact forces. Let's talk about every one of them in detail. Okay, so let's talk about it in detail. So let's take one by one. Please keep in mind all this will be useful now in the next part, which is called as free body diagram, and when we solve problems. So please pay attention now. Okay, so what is weight? So strictly speaking, weight is nothing but the gravitational, okay, so it's nothing but the gravitational force by a planet like Earth on a body kept near it. So imagine you have an apple and it's on the Earth. The apple will be pulled by, yes, the apple will be pulled by the Earth. Okay, something like this. So if this was the apple will be pulled like this by the Earth. The symbol for weight is W, and this W will be m into g. What is m? The mass. What is g? Gravitational acceleration, 9.8 or 10 depending on what approximation you're doing. So that is the weight, or that is the force which is acting on the apple. Understand that. So remember, the gravitational force acting on an object is called as the weight. If you go on another planet, the weight will be different but the mass will be same. If you go in empty space where there is no gravity, then the weight will be zero but still mass will be there. So understand, weight is a force. It's expressed in Newton. Please understand that it is expressed in Newton. One more thing, if I ask you what is your mass, let's say Pandu says his mass is 60 kg. Then his weight, you know what is Pandu's weight? Pandu's weight is 60 G, which is nothing but 600 Newton. So 600 Newton is Pandu's weight, and understand you can also write it as 60 kgf. Do not confuse this with that movie which was released some time back. Okay, I don't know how many of you have seen it, but still. Okay, so 60 kg force is the force exerted by 60 kg mass on earth. That's the meaning of that. Okay, and 600 Newton is in newtons, that's it. All right, so understand that. So a lot of times, see guys, when you just converse with your friends, I know you will ask your friend, oh, what's your weight? And he will be like, oh, my weight is 40 kg. I know traditionally in your colloquial language, you just mean mass, but in physics, weight means force. That's the difference. Okay, great. Sometimes Pandu can be massless, sometimes Pandu can have mass. So Pandu is really flexible. Okay, next thing, normal force. So what is normal force? Whenever two surfaces touch each other, what happens is they experience something called as normal force. So understand, this normal force is nothing but a contact force between, or I will say perpendicular to the surfaces. Perpendicular to the surfaces. So imagine a block kept on a table. Okay, just imagine a block kept on a table. That block has some molecules near the surface, and the table will have some molecules on its surface. When those molecules come close by, there will be strong electromagnetic repulsion between those molecules. So that strong repulsion, all right, will be there between the molecules, something like this. So these are the forces, guys, something like that. Okay, so these are the forces of repulsion. I hope you can see that. These are small, tiny, mini forces near that surface because those atoms can't come close by. If they come close by, that's it. The two molecules will fuse. Okay, so they cannot come very close. Now, the resultant of all these forces, understand, is called as contact force. What is this called? Contact force. The resultant of these forces is called as contact force. That a component of the contact force, yes, a component of the contact force, which is perpendicular to the surface, is called as normal. And so what is normal? A component perpendicular to the surface. So then there will be another component. What is that other component called? That is called as friction. Yes, understand that. So normal is the force which is perpendicular to the surface, and friction is the component which is parallel to the surface. That's how it is. So get this thing straight. Contact force is actually the vector sum of normal force plus frictional force. Magnitude wise, right? Magnitude wise, it is just n square plus f square. Pythagoras. F square plus n square is c square. Get this thing. Okay? So nobody knows how non-contact force works. If you find it out, please let me know. Okay? Maybe you will then also win a Nobel Prize. Anyways, so this is the meaning of friction, normal, and contact force. Get this thing in your head. Please keep writing things. Only then it will enter your head. Come on, keep writing it. Very good, Navmi, Tanka. Very good, Vish. Okay, very good. Yes. Chalo, let's go ahead now. Normal force is done. So let's go to the next force. So what is the next force? Tension. Tension is also something which can be felt before exams, before JEE, but it is also a force. So a thread which is pulled always experiences tension. I have a thread, I pull it, there is tension in it. If I have a thread hanging from the roof and I put a block, that block will pull that thread will experience tension. So if I take a small element, of that thread, right? So that element might look something like this. That element, understand, will experience force from here as well as here. Yes. This part, so this is a small element, right, which I have considered. The lower part will experience pull from here and from there. These are all tensions. And why does tension come? Think about it. That tension comes because of the stretching of the bonds between molecules. So when you pull a thread, the bonds get pulled apart, they get torn apart, and you will see that force which comes now is called as the tension. Obviously there is a limit to which tension can exceed. After that it will break. That limit will be given to you in the case of some problem. So they might give you, oh, the tension maximum can be like 120 Newton. So then you can see whether the tension is exceeding 120 or it's below 120. If it's below 120, you're safe. If it's above 120, then obviously the string will break. So there is always a maximum limit, and you might be like, what is the lower limit? Yes, so there will be a maximum limit. At maximum limit, obviously it will break. And what is the lower limit? Think about it. The minimum value is 0. But when the tension becomes 0, understand you're no longer pulling. The string has become slack. It's not tight. It's not taut. That's what the word will be in the examination. So if tension is 0, that means the string is loose or it's not taut, right? These are the phrases that will be used. Not taut, or it has become slack. You're not pulling it anymore. That's what it means. Yeah. So no, tension is not normal force. Normal force is between two surfaces. Tension is between the molecules, bond being stretched. That's the tension force. That's what it is. Thank you, Pramesh. Come on, it will get more interesting. Okay. So tension, understand, depends on which side you are talking about. See guys, if I take this part, tension will be this way. If I take this part, tension will be this way on that string. That's how tension works. So tension is the force of pulling inside a element like thread or a string or a rope, and tension cannot be 0. If it is 0, then the string is no longer being pulled, it's slack or it's loose. That's what it means. Okay, I hope this is clear. Yes, the tensions will be equal on any point from both sides unless it has some mass. You will see that in the problems when we do it tomorrow. There will be some questions where the string has mass, and then how to solve those problems. We'll be seeing those as well. Okay, great. Thank you, Yunita. Okay, now just let's go to the next part. Let's talk about the spring force. You all would have played with some springs which are there in your ball pens or maybe in the calendar, the ones which you roll. So a spring is a flexible object. When you stretch it, it pulls you back, and when you compress it, it again pushes you apart. So it has elastic property. It tries to regain its original shape and size. And you would have experienced that different springs have different qualities, as in their coil length or their diameter or their material could be different. That will also decide whether a spring is very stiff, like it's very hard to pull, or whether it is very soft, like when you apply small force only, it starts expanding. Okay, so a spring's stiffness can be given by something called as a spring constant, and that's what I'm going to give you in a bit. Now understand, there are few things. Okay, one second. Yeah, so a spring always has something called as the natural length. Natural length is that length where the spring will not experience any kind of forces within itself. It's relaxed, it's cool, it's aram se resting over there. When you increase the length, right, then it is stretched. When you make the length short, then the spring is compressed. So imagine if I have a spring right now. Now this is, let's say, at natural length, and now I take that spring and I elongate it. So this is the extension. I will have to apply some force on it to pull it. So that force is found out to be proportional to x. The force which you apply on the spring is proportional to x. This is force on the spring. Understand that. Okay, and that constant of proportionality is called as k. This k is called as the spring constant. What does this spring constant depend on? It depends on the material, the coil material of the spring, and also the shape and size of the spring. What is the unit of the spring constant? It is Newton per meter. It tells you how many Newton force you need to extend it per meter. That's the meaning of this value K. Understand that. So, if I stretch a spring by 1 meter and I find I need 10 Newton force, then the spring constant is 10 Newton per meter. Similarly, if I take a spring and compress it by 1 meter and I find I need 20 Newton force, then the spring constant is 20 Newton per meter. More the value of K, higher the stiffness, more hard it is, it's harder to, extend or compress the spring. Yes, I hope this is clear. So K will be given to you, don't have to worry, else F and X will be given in some other way and you have to find K. So either ways. Yeah. So Suhas, understand elasticity is a property by which a body regains its original shape. So spring is elastic because it tries to regain its original shape. So spring is elastic body, and spring when extended by an amount X, then the force is found out to be proportional to X. So that's why I'm saying the proportionality constant is K. Yes. The spring constant generally has constant value in JEE, but if its value changes, then you have to do it by integration. We'll be doing those kind of problems in our advanced sessions. Don't worry. Okay. So the value of K can change, but how it changes will be given to you. Don't worry about it. All right. All right. Okay, great. So I hope this is clear. What is a spring force? So the force exerted by the spring or on the spring is proportional to X, magnitude wise, depends on shape and size, and the material unit is Newton per meter. Okay. Now let's talk about, since you are now understanding different kinds of forces, let's talk about balanced forces like I was saying before this. So imagine there are two Pandus out here and one is nicely playfully enjoying, he's just hanging over there, and one guy is, I don't know why, sad because maybe this guy didn't give him a chance to hang in over there. So if I ask you, what are the forces acting on these Pandus? Let's try this out, guys. Think about it. On this Pandu, there will be one force, that is this weight, right? So the weight of the Pandu will act down, and do not forget he's standing on the ground peacefully. So there will be also a normal force acting on him. And think about it, the normal force, if I take it as upwards as positive, right, minus the weight, because weight is downwards, will be 0. If this is 0, the net force is 0, then I can say it is balanced. The reason why I'm saying it is balanced is because this net force, sum of all the forces, is 0. That is the meaning of that. Correct. Similarly, in this case, the Pandu's weight is down, and I think his hands are under tension, or you can also say that there is a normal force by the rod on the hands. So there will be these two tiny mini normal forces, N1 and N2. I hope you can see that. And in this case, if I again take upwards as positive, N1 plus N2 minus W will be 0. So you can see again the net force is equal to 0. So it's a balanced system. Yeah, these normals can be equal, can be unequal, depending on how much force is applying by his individual hand. So it depends whether the situation is symmetric or not. I hope this is clear how forces are balanced or not balanced. No, K can never be negative. If K is 0, then the spring is useless. I mean, there is no spring force only. So there is no point having K 0. Okay, very good guys. I hope you guys are understanding and having fun too. Are you guys having fun? Come on, please write it out in the chat box, yeah? So 16s, you will find the value of K by the given information. Force will be given, X will be given, you can find K. It will be given to you generally. All right. Great. Amazing. So let's go to the next part now. So you will be like, what if the net force is not 0? Do not worry. If the net force is not 0, to see that, first let's talk about momentum, guys. That's very important. So momentum is nothing but mass into velocity, and it's a vector quantity. So whatever is the direction of velocity, that's the direction of momentum. And the unit of momentum is kg meter per second. Understand that. So that is momentum. Now, a small car will have less mass, but if it travels very fast, then it can have the same momentum as a big truck traveling with very small speed, because the product might be same. So momentum is the effect of mass and velocity. I hope this is clear. Okay, so that is momentum. I hope you're making notes quickly. Very good, very good. Let's go ahead. So how do I use it over here? So that is Newton's second law. So Newton's second law says that the net force, okay, the net force acting on a body is directly proportional to the rate of change of momentum. That's what Newton's second law says. So I will write it in words: net force acting on a body. Now let's write it symbolically. Net force is sigma F. Proportional, I will replace it with equality, and or if you want, I'll keep it proportional. Later on we can figure it out. And rate of change of momentum, it's dp by dt. Remember, I have taught you derivatives. Rate of change of anything is derivative. All right. Rate of change of pressure is dp by dt. Rate of change of velocity, dv by dt. Rate of change of momentum, dp by dt. And in SI units, what happens? That constant of proportionality becomes 1. Okay, because of the way we define it, right? That constant of proportionality is 1, since 1 Newton is equal to 1 meter, 1 kg meter per second square. That's how we have defined it. That's the reason for that. Okay, so once I get this, here is what I'm going to do. Momentum was mass into velocity. Okay, so what I'm going to do is write this down as m into v bar by dt, but m is a constant generally. In JEE problems, mass will be constant. Variable mass problems are not there for you. So it's been cancelled from the syllabus, so do not worry. So mass comes outside, and what remains inside, guys? dv bar by dt. But what is dv bar by dt? I hope you know that. That is nothing but acceleration. So net force is mass into acceleration. So that is a modified form of Newton's law. Actually speaking, this is Newton's second law. Understand? But this is a simpler version of Newton's second law when mass is constant. Okay, since m is constant, that's why I have taken it out. So remember that. Okay, so we are going to use this because mass will be constant for most of our problems, so don't worry about it. So first thing will be to find unbalanced force, which is the net force, and then you will write it as m into a. Don't worry, you are going to see the problems. Okay, so rate of change of anything which understand is delta p or dp by dt. What is dp? Change in momentum. What is dt? Small time interval. So dp by dt will be how much momentum change in how much time. So that is it, rate of change of momentum. Okay, real law because you can use it. That's why. All right, Hanu. Okay, great. So now let's look at the last part of Newton's law, and then we'll start solving problems. Very good problems I have. So do you experience karma? Do you guys believe in karma? Do you guys believe in karma? Yeah, you guys believe in karma? What is karma? Karma is if you do good to others, you will get good things, and if you do bad for others, eventually life will play it out and bad things will happen to you. Some people don't, some people do believe, most of you believe. So in the world of physics, there is karma. And what is that karma? Here it is. If something applies force on the other thing also applies force on that first thing. Look at that. That is self-explanatory. Yes, Newton believed because that's how things are around us. So that is Newton's third law. So according to Newton's third law, for every action there is a reaction force, but they don't cancel because since they act on different bodies. So remember that they act on different bodies, that's why they do not cancel out each other. Very good. So this person's gun is applying tremendous force on the bullet. By Newton's third law, the bullet also applies the same force on the gun plus the person, so that's why the person moves back. Understand, gun applies force on the bullet, that's a separate body. Bullet applies force on the gun plus the person, that's the other body. So these forces do not cancel out each other. Understand, they're on two different bodies. I hope this is clear. Yes, yes. So let's concentrate on the topic. I can talk about black holes, but the problem is then you will start getting confused and you will not understand it. I have special lectures dedicated for black holes, so wait for it. Okay, so in my regular classes I have been talking about black holes and stuff like that. So understand, you need to maintain discipline in the chat box, and I would request the administrator to please kick them out. Okay, so how do we represent these forces? How do we represent these forces? Using free body diagram. So what is free body diagram? Free body diagram is nothing but you have many bodies, okay, touching each other, not touching each other. You take any one body. Let's say I decide, okay, this is my body, and show the forces acting on that body. Whatever forces are acting on that body. That is called as free body diagram. So this is my system which I have chosen. So system is something of your choice. It's my choice. And what are these? These are your external forces which are acting on that system. And in the end, show one more thing. Also show whether it is accelerating or not, and which direction it is accelerating, in case you know it or you can assume it. So what and all will you show in a system and FBD? Understand? So in a free body diagram, always choose a body out of many bodies, then show the forces, and then also show the acceleration if you know it, else assume it in a particular direction. All right, so that is nothing but free body diagram. Well, I think you'll better understand it if I show you some examples. Let's take these examples, only then you'll get a hang of it. So imagine there is a block kept on a table. So there are two bodies over here. I'm going to isolate only this guy because I'm teaching you how to draw FBDs, and I want to draw the free body diagram of that mass. So what are the forces on that mass? Very simple. One is mg, which is the weight. So that's the weight. Second force is the normal force. That normal force will act from the table. So this mg is on the block by earth. Understand? And this normal is on the block again by the table. I hope this is very, very clear. I hope this is very, very clear. And last thing, you have to also show the acceleration. Since the block is at rest, so you can just mention the word that it is at rest. So acceleration is 0. And since acceleration is 0, can I not say n is equal to mg? So guys, n is equal to mg. I hope this is clear. No, inertia is not a force. Inertia is a property. Okay. Now my question to you is, are these forces action and reaction? Are these forces action and reaction? Yes or no? Come on. Normal and mg, are these action and reaction? Yes or no? No, yes, yes, equal, opposite. Think about it. Well guys, the answer is no. I'll tell you why. Who is applying normal force? The table. On whom? The block. So if I call this as action, you know what is reaction? the reaction will be on the block, sorry, on the table by the block. Where is that? That is here. This is action reaction. This is reaction. Yes, please understand that. Just because two things are equal and opposite does not mean it is action and reaction. Who applied this normal? Table. On whom? Block. So the reaction will be on the table by the block. Okay. Another thing, we'll be like, okay sir, then what about this? What about this? mg, if I call mg as action, then you'll be like, sir, where is the reaction? Think about it. Who is applying the force? Earth. On whom? Block. So what you need to do is draw the earth. Draw the earth. And the earth, guys, will experience exactly mg force like this, and this is the reaction. Understand that. This is the reaction. So on the block by the earth, this is on the earth by the block. That's action reaction. Yeah, that's correct. A lot of people I know, they just think, oh, this is normal, this is action, this is reaction, or this is action, that is reaction. That is wrong. Think carefully. So this example proves that. So Suhas, friction is completely different. Friction is the horizontal, it's the component which is parallel to the surface. Newton's third law is a general law. Understand? So magnitude wise, Kirito, not the direction wise. So n, yes, if you want, you can write it as n minus mg is equal to 0. Yes, but once you take it to the other side, it will become n is equal to mg. Okay, great. Let's go ahead. Let's go ahead. Let's see the next FBD. I have some amazing FBDs. Okay, there is a block which is suspended by a spring. Let's see what will be the forces acting on the spring and on the block. Okay, so let's draw the free body diagrams. Come on, let's do this quickly, guys. Okay, on the block, what will be the force? One will be mg, right? But the spring will be stretched. So what will the spring do on the block? The spring will pull the block up. So there must be a spring force over here. And if it is at rest, then the acceleration will be 0. The acceleration will be 0. If you draw the free body diagram of the spring, then on the spring, there will be Fs here. Yes, the spring will be pulled down like this by the block, and there will be a normal reaction here by the roof. Yes, by the roof. The roof is holding it. Else, if that normal was not there, the spring will fall down. It's not falling down, so there must be a force there. And believe me that if I call this Fs as the action, then this Fs is the reaction. Think about it. If the block is pulled by the spring like this, the block pulls the spring down like that. I hope this is clear. These are action and reaction. Normal by the roof. You can call it normal, you can call it tension, whatever you want to call it, but there will be some force. Just call it some force will be there. Some contact force will be there. You can call it whatever. Yeah. Normal is not always upward, Sonu. You will see some examples now. Hold on. Just think about it. Okay. If I'm pushing the roof like this, where is the normal force on me? Down, right? So normal is not always up. If I push the force, if I push the roof, sorry, like this, normal will be down. Pulley problems is for next session. First understand these things. Pulley problems may, or else you will get confused. Right? There are very good problems in pulleys. Okay. So now, if I ask you, what is the value of Fs? Well, Fs will be K into X. Remember? Where X is the extension. So the spring might have got extended by X amount from its natural length maybe. And if I want to find the X, it's not a big deal because I know one thing. Fs minus mg is 0 and Fs is nothing but Kx. So Kx will be equal to mg. So therefore, X will be equal to mg by K. So that will be the extension. I hope it is clear. That's the extension of the spring. Thank you, Prajwal. Okay. I hope this is clear. Very good, very good, very good. Yes. So there is that normal on the block itself is called as the spring force. It's not kept on the ground now. It's just suspended in the air. So there is no normal. Okay, great. Now, let's see more FBDs. Let's take a wall on which a string is attached and a person is pulling that string. Okay, so let's talk about tensions. So now I have made 3 different bodies and we'll try and draw the free body diagram of all the 3 different bodies. First, let's take the string. On the string, there will be a force of tension here, and on this side also tension. And since it is at rest, it's at rest, right? So because of that, this tension and this tension should be equal. So that's one thing. Next, if I talk about this tension, who is applying it? The person is pulling the right end of the thread. So the thread will pull this end of the person like this. These are action-reaction pair. Action, reaction, Newton's third law. Action-reaction pair. I hope this is clear. Now, if you look at the person, there will be even more forces. One will be its own weight, then the normal from the ground, and one more force should be there. Yes, friction. Because if friction is not there, the person should start moving like this. So the friction is preventing him from moving. So the friction on the person is towards that side. Okay, so that's how it is. Don't worry, Vish, just follow this. I'll be taking more problems, then you'll slowly understand it. Don't worry, just follow whatever I'm saying and you can always replay it. Don't worry. Okay, Vish? Okay. Guys, Babita, Lamy's formula and all are mathematics. Learn the physics over here. Lamy's formula will be taught to you as a sine rule in maths, in triangles. Learn physics over here. That's what most of the institutes do. They end up teaching maths in physics and the joy out of physics is just taken away. A lot of students ask, sir, what about basic maths? Like I have been telling you, basic maths is taught over here as an application. So understand the application, understand the fun in physics. Don't look at the maths. Maths will be dealt in separate subject. You have a separate subject for that. Okay. You don't have to generate friction. You just have to make the surfaces rough. That's it. So because he's pulling it there, understand he will have a tendency to slide here. So that's why friction will be towards that side. Because if you are pulling the rope here, pulling the rope, you will get pulled there. So the friction will push you back. That's what is happening. Okay. Next, look at this block which can slide on this surface. What kind of forces will be there? So number 1 force, there will be a normal force. Yes, there will be a normal force which is going to be perpendicular to the surface. Somebody was asking, is normal always up? No, you can see that. It can act at an angle. Next, there will be weight which will be mg. And it can also accelerate down. So it can accelerate down if there is no friction. But if there is friction, then the friction will act like this. If it is sliding down like that. If it is sliding down like this, friction will prevent the motion. Yeah, if there is friction. If no friction, then this is not there. Okay, so that's how FBD will look like. Next, this is very interesting. Block on a block. How will the FBDs look like? Observe this carefully. Block on a block. Let's say I call this M1. Let's say I call the below one M2. On this block, what are the forces? One will be mg. Second will be normal, but I'll call it N1. Who is applying this normal? The lower block. On whom? The upper block. So the reaction of this normal will be over here. Now I have seen lot of people show like this mg. This is wrong. Mg does not act on the lower block. What acts on the lower block? Understand, that is N1. Yes, action reaction. Yeah, the value of N1 is mg, no doubt. But the force that acts is normal. Action reaction. Now, next, what else is there? There is weight down, but that is okay. I think I had labeled them as M1G and M2G. So this is M1G and this is M2G. The weight of the block because of the earth. And because it is resting on a surface, there will be a normal over here, N2. That's it. And since they are at rest, A is 0, A is also 0, and because they are at rest, here is what I can say. For this block, normal minus m1g is equal to 0. Therefore, n1 magnitude wise is weight. For this guy, I can say the upward force n2 minus m2g minus n1 is equal to 0. Therefore, n2 is equal to n1 plus m2g. But I know what is n1. It is nothing but m1g. So it will be m1g plus m2g. That's what you are getting n2 as. Yes, I hope this is clear. Okay, so let's go to the next problem. This is what you should understand. Akhil, you will be getting flash extracts. Don't worry. You will be getting flash extracts. And you can always replay the session, and you will be also getting the blank slide notes so that you can use it as workbook. Okay, look at these Pandus. Who do you think will experience the greatest force? Think about it. If I had to talk about the forces on these Pandus, guys, think about it. Okay, so let's draw FBD of each Pandu one by one. Let's take the lowermost Pandu. Lowermost Pandu ka, it will be M3G. On him, there will be a force. Okay, there will be a force upwards like this. I can call it tension T3. है ना? Force acting on this. And then if this person is pulled up by T3, this guy in the middle will be pulled down by T3. Apart from that, his own weight will be there, M2G, correct? And then he is being pulled up by tension T1 or tension T2, you can say. He's being pulled up by tension T2. And who is pulling him up? This guy's leg. So his leg will be pulled down by tension T2. And then again there will be his own weight, M1G, and then this rod will pull him up by force of T1. That's how the FBD will look like. That's how the FBD will look like. I hope you are getting a hang of FBDs. That is very important. I hope this is understood. Okay, great. Jay, don't worry. Once you understand drawing FBDs, you can find it out very easily by drawing the FBDs. Okay, great. It will not, yeah, FBDs are very similar, but the values will be different. Who will experience more force? T1, T2 or T3? Think about it. T1 will be the highest. He has to, that guy on the top will have to apply a lot of force. This guy, decent on his hands. This guy will be the least. He's cool. This guy will be highest. This guy will be medium. This guy will be the least. Yes, correct. So that's how you draw FBDs. You can make the equations. T1 is T2 plus M1G. T2 is M2G plus T3. T3 is M3G. That's how you can get it. So let's do some more problems. Let's apply these FBDs in some problems. Okay. So get ready for some problems, guys. I hope you guys don't mind if I extend the lecture by more 15 to 20 minutes. Okay. So let's do this. So let's take somebody's mass. Somebody can you give your mass, please? Can somebody give your mass, please? Yeah, somebody's mass on the chat box. So, acha. Okay, Suhas is 110 kg. Okay, so Suhas. So let's take Suhas. So Suhas dude is 110 kg. Interesting. So what will be the reading shown? So here is the answer, guys. First, Suhas's weight will be down and there will be a normal reaction. So normal minus mg is 0 because he is at rest. So therefore n will be equal to mg. M is 110, g is 10. So this will become 1100 Newton. So that's the weight of yeah, that's the weight of Suhas, and that will be also the reading shown. Yeah, that will be the reading shown. So always remember, whenever the reading shown on a weighing machine is asked, always find the normal. Why the normal? Because whatever force the weighing machine applies, the same force is applied on the weighing machine. So you are pushing the weighing machine by the normal force. So always find the normal force. That is the reading. But that is in Newton. So what happens, guys, on the scale, since you see kg, right? What they do, they remove 1 0 so that you get the answer in kg. That's the only difference. Yes. I hope this is clear. Okay. Look at this question. Let's look at this question. Two blocks, 4 kg and 6 kg being pushed by a force. Looks like a simple problem, but trust me, it is not. We have to find not just the acceleration, but also the contact force between them. So what we'll do is, we'll first separate those two boxes apart, matlab not literally, but just for the diagram, free body diagram, and then let's see how to go about it. Okay, so here is the thing. Think about the forces acting on A. What are the forces acting on A? Well, there is one external force. How much is it? 20 Newton. Then the weight is there and there is a normal, but I don't think anything will happen in the vertical direction, so I will not even bother about it. But still, if you worry about it, then just show it. It won't matter. Okay. The surface is smooth. That's what we'll assume. And because they are in contact with each other, there will be an extra force from this side, B exerting on A. So some normal force, let's say call it N3. Now because B exerts on A will also exert on B, and that is N3. Please understand, 20 Newton is applied on A and not B, so do not show the 20 on B. That force will not move there. It is only on A. What is between A and B? That is some other force, N3. Next, B's weight, which is M2G, and the normal, of course, and nothing else from that side. And do not forget, I have always told you, show the accelerations. So if A accelerates with A, even B will accelerate with A. Why? Why won't it be different? Because both of them have to move together. If both move together, won't their accelerations be same? Yes. So their accelerations will have to be same. That's it. Now just write Newton's second law equation. So what is Newton's second law equation? Net force is mass into acceleration. Just use this. So what is the force over here? Which direction will you worry about? I think you'll worry about x direction. So what is the force? N3. What is the mass? Okay, the mass of B, guys, is 6. So it is 6 into A. That's it. That's one equation. Over here, what will be my equation? It will be 20 minus N3. Why minus? Because this is positive, though this is negative. So this is the net force. This is that LHS. This is that LHS, correct, is equal to mass, which is 4 into A. Now you'll be like, what to do? Or just take that N3 and substitute it over here. So it will become 20 minus 6A is equal to 4A. Therefore 20 is equal to 10A. Therefore A is equal to 2 meters per second square. Once you get A, put it over there and you will get N3 as 12 newtons. So we have found out both the answers. What is the acceleration of the blocks? 2. What is the normal force? What is the contact force between them? 12 Newton. Interesting. Remember, had you taken the complete thing as a system and not split it up, you will never be able to find N3, because N3 will then become internal force. Because I have split them up, N3 has become external force. Get that in your head. Okay? Chalo, let's go to the next question then. Let's look at this block which starts sliding down. What is the speed of the block after time t? Okay, so that's the question. Speed of the block after time t. To find speed, what will I need? Kinematic equation. For kinematic equation, what will I need? Acceleration. For acceleration, what will I need? Free body diagram. So let's start with it. So let's start with free body diagram. Okay. So what will be the free body diagram? Yeah. One will be the normal force, but the weight which acts down, I won't keep it like that, which is mg. I will try and split it. Why will I split it? The reason of splitting is I know that this block is going to accelerate down like this. So I need to figure out what is that force which acts in that direction. So for that, understand, if this angle is theta, Then if I take this mg, I can split it up into two components. Believe me, even this angle is, even this angle is theta. And you can see that very easily if you extend it this way. This is the technique I use. This is the technique. I divide it into 8 parts, and then I see that this angle is theta, right? This was the inclined plane. This angle was theta. So every alternate angle will be theta. That's the best way of doing it. Yeah. So if this is mg, clearly I can split it up because this is theta. Remember, the one which is closer, adjacent, is always the cos. So it is mg cos theta, and the other component is mg sine theta. I have told you about vector resolution before. I hope this method is very simple wherever that angle confusion problem happens. Okay, so now very obvious to see that normal and mg cos balance. Normal balances mg cos. Why? Because there is no acceleration like that. It is not flying up. But in this direction, you can see if I use net force as ma, what is that force? mg sine theta, ma. So therefore, acceleration is, think about it, mm goes g sine theta. So that's the value of acceleration. Now, that's not done. We have to find the velocity. How do I find the velocity? Use v is u plus at. What is u? 0. What is a? G sine theta into t. So therefore, v is g sine theta into t. That's the final answer. I hope this is clear. I hope this is clear. Thank you, Anu. Thank you, Navmeet. Pramesh, don't worry, Wazim sir will come. Yes, very good, Saurabh, Sonu, very good, very good, very good. Okay, let's go to the next problem then. I'm going to do variations. So, the next variation is, how much is the frictional force and contact force if the mass is not moving because of friction? That's the variation. How much is the contact force? Yes, how much is the contact force and the frictional force? Well, that's very simple. What we'll do? Again, draw the free body diagram. This is normal. This is mg. And it will prevent it from sliding down. So where will the friction be? Friction will be here. That's it. And the acceleration is 0. And we can do one thing. We can split this mg. Instead of showing this mg like this, let's split it just like we did it before. Assuming this angle is theta. So we'll get this as mg sine theta. And this will be mg cos theta. So the question is, what is the frictional force and contact force? So clearly, in this direction, which two forces are cancelling out each other? Look at that. So friction is cancelling out mg sine theta. So that's the answer for friction. So friction is mg sine theta. This is along the inclined plane. That's what I got. And in this direction, that is perpendicular direction, normal force is mg cos theta. Frictional force is found out. Contact force. What is contact force? Do not forget. Contact force. I had told you, contact force is a resultant of friction and normal. Do you remember that? So, what will be contact force? Root of n square plus f square. So, what will it be? Root of mg cos theta. mg square cos square theta plus m square g square sine square theta. Now, what is cos square theta plus sine square theta? What is cos square plus sine square? It is 1. So what will it be? Root of m square g square into 1. And that is nothing but mg. So that is the value of contact force. Yes, correct. A lot of you have got it. Aren't you having fun solving problems? Isn't it simple? Are you guys getting a hang of it? Isn't it simple? So that's the contact force and the frictional force. Please understand, contact is resultant of friction and normal. Next, spring is there. Same situation, the block will extend. how much is the extension of the spring? Again, same thing, guys. Come on, let's do this. It's not that difficult. There will be normal force, and mg, I will already split it. Mg cos theta, and there will be mg sin theta. Why is the spring stretched? Because of mg sin theta pulling it down the incline. So think about it. The spring force on it will be this way. So this will be the spring force, and that is why it is at rest. That is why it is at rest. Yeah, let's assume the spring, the system is on a smooth surface. Because it is at rest, can I not say along the inclined plane, spring force will be equal to mg sin theta? And do you remember, if the extension in the spring is x, how much is the spring force? It's kx. Think about it. It is kx. So kx is equal to mg sin theta. So therefore, x will be equal to mg sin theta divided by k. That is the answer. Very good. Gopal Krishnan, if the entire thing moves, then it is becoming a non-inertial frame. We'll be dealing with such type of questions in another session. Okay, I hope this is fine. Great. Now, shall we take a very good problem? Shall we take a very good problem, guys? Because I have a very good problem for all of you, and that will be very interesting. Okay, let's look at this. This is very good problem, advanced level question. If two blocks are suspended by springs and they are at rest, what is the extension of each spring? That's what the question is. Let's do this. Constants are also given. Let's do this. First, I'll split them apart. Consider the upper part separate, consider the lower part separate. Just consider it separately because it will be easy to solve the problem. Oops, 1 second. Okay, so look at each part and then try to draw the free body diagram. For the lower part with the spring and the block, the downward force will be mg, and this spring will be extended by some amount. So let's just say that the spring force on it, because think about it, once it stretches, right, itself, there will be force from the top and the force from below. Okay, so there will be a spring force like this. I'll call it Fs2. Now, if you look at this diagram, there is nothing else apart from that. The acceleration is 0. So I can clearly say Fs2 is equal to mg. And what is spring force number 2? It is the spring constant. What is the spring constant? 2k into its extension. That will be equal to mg. Therefore, understand x2 will be equal to mg by 2k. So that is the extension of this spring. In fact, the way to solve this problem is, for the lower spring, forget that the upper part exists. It's as if it is suspended from a roof. Just figure out like this. It's just extending that spring. So how much will the spring extend itself? Whatever force is acting on it. How much force is acting on it? Mg. That's all. Great. Now for the upper part, there comes a problem. What is the problem? There is not only 2 mg force, but this spring force which this block was applying on it, that guy's reaction is also there. This spring lower is pulling that 2m block. That's the problem. So therefore, understand the spring force 1 which is there, which is pulling this 2m block up. This Fs1 will be equal to 2mg plus Fs2. But do I know the value of Fs2? Yes, it is mg. So what will this become? 2mg and 3mg will become 3mg. But what is the spring force number 1? It will be just K of that spring into that guy's extension. And what is that guy's extension, guys? It is just 3 mg by K. That's it. Very good. So let's think of it this way. In a spring which is extended, the coil has tension. So tension can act even in a spring, in a thread also. Understand? But spring force is something exclusive for an elastic body like a spring. I hope that's fine. Interesting? Interesting? So let's see how many of you can solve. Let's see how many of you can solve this part. How many of you can solve this part, which is the difficult part? What if I now remove or cut the lower spring? What will be the accelerations of both the blocks? What will be the acceleration of both the blocks? How to solve this question? Let's think about it. Well, trust me, it's not that difficult. Once you cut this spring is gone, destroyed, gone, cut. There is no extension. So the extension is 0, gone. It's destroyed completely. Alright? So forget that there is a spring. So the only force acting on this mass is nothing but mg. Now if there is only one force acting on it, what will this mass do? Obviously it will accelerate downwards. So if there is only one force, mg will be equal to ma. So what will be the acceleration of the lower block? It will be g, downwards. I hope this is clear. I hope this is clear. Now think about the other block. On the block on the top, please understand there is 2 mg force down, but because there is no spring below, there is no other force apart from 2 mg below. But this spring was already extended. Remember, this entire system was extended, and then you remove the lower spring. It will take some time for the spring to come up. So it has not yet come up. So the spring force will still be the same as before. Yes, the spring force will still be the same as before. And the reason for that is since it has not yet relaxed itself. That's the reason for that. And now let's think which force will be more. Well, I think I just calculated Fs1 in the previous slide, and I remember it was clearly 3 mg. It was clearly 3 mg. So where will it go? It will not come down. Yes, it will go up. This will be the acceleration. And now you can see if you applied for this block, so 3 mg minus 2 mg, bigger force minus smaller force is 2m a1, and that's why, guys, a1 will be 3 minus 2 is 1, so it will become g by 2, but this is upwards. Interesting. Madhvi, Suhas, don't worry, it's very simple. This 2m had already stretched that spring, so that spring was already stretched, so that force will still remain the same. How much was it? 3 mg. I have imported this answer from the previous slide. I hope this is clear. So it will take some time, it will take some moment for itself to adjust. It has not yet come back to its relaxed state. So that's why the spring force is still there. But from below, since you have cut that spring, it has gone. So once spring force gone, only 2 mg there, so it will go up. That's what has happened. I hope this is clear. Very good. Interesting, guys. Okay, so I have kept some more questions. You can solve it, and I would be interested to know what the answers for this question and this question and this question is. So 3 questions. You can have a look at it. Put up all the answers in the comment section below. I'll be really interested to see what your answers are. All right, I'll post the answers on Telegram group. Okay, this answer, okay, This answer, the answers will come up on the Telegram group. Yes, answers will come up on the Telegram group. And this one, put up in the comment box. Yeah, very good, very good. So try this out, guys. I hope you have understood, you have leveled up your knowledge now. Do not worry about these questions. I'll be posting the answers in the Telegram group. All right, do not worry about it. I have kept a lot of questions today. I honestly didn't feel that I will be able to solve so many questions, but somehow we have solved so many questions and you have learned a lot. And do not worry, even if you did not understand 5-6 questions or 3-4 questions, it's okay. Watch the replay again and again. Watch the replay. You will understand it. Okay, don't worry, it will always take some time. And this session and the next session's drill will come together after tomorrow. Okay, so after pulley and strings, I'll be posting the drill. Okay, all right. I hope, guys, you have enjoyed the session. Do not forget to join the Telegram link, and I'll be also posting the extracts of the previous sessions very soon. Don't worry. Okay, okay. So I hope you enjoyed. So please like the video, guys. Please like, or else YouTube won't suggest you these videos. Thank you, guys. Bye bye. Take care. Yeah. Have a stay at home. Yeah, take care. Bye bye, Gopal. Bye bye, Navmi, Pratyush, Sonu, Krito, Konika, Navmi, Rishabh, Sonu, Anu, Mariam, Juma, Parmesh, Suhas. Okay, take care, Anu, Kashyap, Dona, Barani. Bye bye. Take care, guys. Take care. Yeah, good night. See you guys tomorrow at 7 p.m.